Hi guys, hope you're all keeping safe. As promised earlier, I'm back again with another episode of the Manus Linguistics series. Today we'll look at a problem which is actually quite close to my heart. So this is the area of comparative or historical linguistics. So the question that we'll try to address is how can you use quantitative methods and algorithms to compare languages and dialects? So let's get started. So we often hear things like Swedish is more similar to Danish than to Spanish, and Hindi is more similar to Punjabi than to Thai. So these are impressions that speakers of these languages have. But why is it that some languages are more alike than the others? And is there a way to formally characterize this difference? So linguists have actually studied this topic for quite some time, and this was actually the very much the focus of early linguistics. I should say, like 19th century, 20th century, the first half of 20th century was exclusively focused on this problem. So languages and linguists think that languages can be similar either due to descent from a common ancestor. So this would be the notion of language family, for example, Indo-European family of languages and or Uralic family of languages. So this would be a genetic relationship. And languages can also be similar due to convergence as a result of extensive language contact and multilingualism. So what do I mean by this? So you can have linguistic areas like, for example, South Asia, where you have languages of many different language families in contact over the last 2-3 millennia at least, and you also have extensive bilingualism, multilingualism. As a result of that, these languages from different language families actually show some similarities, but those similarities should not be confused with you know similarities due to a genetic relationship. So yeah, like I mentioned, comparative historical linguistics is concerned with studying genetic relationships among languages. So historical linguists compare languages and try to find evidence of genetic relatedness. So this is actually a diagram that I found on the internet. So this was, I think, on the cover of Guardian a few years back. So this shows different language families. So yeah, so they say it's old world language families, but that's a very Eurocentric kind of notion, because there are many old world families which are not shown here. Like Dravidian is probably one of the oldest language families, but it's not really shown here. Similarly, there are many other language families in Africa which are quite old. But yeah, anyway, so here what we see is in the Indo-European language family and the Uralic language family. So you can see in Indo-European there are different branches, like the Indo-Iranian branch and the European branch, and within the European branch you have Slavic, Romance, Germanic. These are further branches, and then within the Indo-Iranian again you have a further split between Iranian and Indic. So this is to give you a feel of the concept of language family. So this is how linguists think in terms of about relatedness among languages. We think that there are these language families, and languages are related because of descent from a common ancestor. So the idea is that all Indo-European languages descend from a common ancestor which is unattested. So we don't have any evidence of that ancient language which diverged into all these languages that we find evidence for, that we actually observe in the world today. Um, so yeah, so and then you also have another example of Uralic. So you can see that Uralic again has Finno-Ugric, and then which branches into Finnic and Ugric, etc. So Hungarian is an example of a Ugric language, and Finnish, of course, is like one of the most important Finnic languages. So yeah, I won't belabor the point. So we have language families, and languages belong to families. So this is the whole point of this diagram. So in this presentation, I'm not going to go very deep into comparative linguistics. So this is only meant to be a brief primer for people with no background. I will cover three concepts here, but then it will help you to read about each of these things in order to appreciate these concepts better. But these are the minimal things that we need to go through the tutorial today and understand uh, the rest of the content. So the comparative linguists have the most important tool that they have is the comparative method. And the comparative method is used to identify one of the steps in the comparative method is to identify systematic sound correspondences. We'll look at what they are in a bit. And then it's all the goal of this whole enterprise is to be able to reconstruct the ancestor language, which is known in historical linguistics terminology as the proto-language, and see how the ancestral language has changed into all the languages that we see today. So here I have some examples from Indo-European languages. So these words are from different Indo-European languages: Sanskrit, Greek, Latin, Gothic, and English. So all of these words are so first of all, these words are called cognates because it's the same word in different genetically related languages. So if you see the word for foot, it more or less looks similar in Sanskrit, Greek, and Latin, and Gothic and English also, they look a bit similar. So pad, pod, ped, footus, and foot. Similarly, the word for father, pitra, in Sanskrit, or pitar, and then Greek is pater, and Latin is pater, and Gothic is father, and English is father. So yeah, I haven't given the phonetic transcriptions here. I wanted to kind of keep things simple and not confuse you with too much detail. But these are cognates. So the first step is to collect these cognates for different languages. If you want to establish genetic relations among a set of languages that you think are related, so first collect cognates, so cognate sets. So these are the different cognate sets. And the second thing I want you to observe is, as you can see in the first two examples of foot and father, the words for these two concepts, you see a kind of a systematic sound correspondence. So where you see the bilabial p in Sanskrit, Greek, and Latin, you see the labiodental fricative f in Gothic and English. So similarly, if you look at the words for dog and 100, it's kind of similar. So in Sanskrit you see the sh, the sibilant, while in Greek you see the velar k. Latin as well, you see so it's written here using a c, but it's actually pronounced as a k. And in Gothic and English you actually see the fricative h. So there is this notion of like systematic sound correspondence, and all words with a particular sound in Sanskrit will have a different sound. So pa in the word initial position in Sanskrit corresponds to fa in the word initial position in English or Gothic. So that is the notion of a sound correspondence. So first we collect the cognates, and then from the cognates the linguist identifies systematic sound correspondences. And once you have systematic sound correspondences, you can actually see the you can infer the mechanisms of language change. So what do I mean by that? So again, I won't get too much into the details, but I will just give you an example of a very famous observation by the German linguist Jacob Grimm. So he observed this chain shift in the Germanic set of languages. So he noticed that voiced aspirated sounds change to become voiced, and voiced sounds change to become voiceless, and voiceless sounds change to become fricatives. So this was the first evidence of systematic sound change. So we can actually go back and see this in this. So you see that Gothic and English. So English is a Germanic language. So you can see that where there is the um, voiceless stop in Sanskrit, Greek, and Latin, per, you actually have the fricative in English, fur. Similarly, when you have voiced aspirated, so for example in Sanskrit, the word for brother, bhra, bh, you see the voiced, so the aspiration is lost. So here you see b. So bh becomes b, p becomes f, and yeah, there is a few other changes. You can read all about that. So actually, the Wikipedia article on Grimm's law is pretty good, I would say. But the main point of Grimm's law, this is actually the starting point of, I would say, this was the starting point of comparative historical linguistics. So Grimm's law, uh, made studying sound change a thing in linguistics. So this is the first evidence of systematic sound change. So I'll talk about one other example. So if you look at the velar and palatal stops in Indo-European languages, yeah, this example, these sound correspondences by the way, I took them from Encyclopedia Britannica page on Indo-European languages. So these are again sound correspondences across different Indo-European languages. You have Greek, Latin, Gothic, Sanskrit, and Slavic. So here, what do we see? Where you have velars, so the velars in Greek, Latin, and Greek and Latin correspond to the sibilant in Sanskrit and Slavic. And yeah, again, so this is the palatal sibilant, and then you have the palatal glide in Sanskrit. And then when you have uh, when you have where you have where you have so the Sanskrit velars are actually labiovelars in Gothic, and they are even like labiodental. So the idea is that in order to account for this series, in order to account for these sound correspondences, you have to propose proto sounds in the ancestral language, and also suggest mechanisms of change. How could the sound in the proto language change to the sounds in these individual languages? And those mechanisms of change should be well attested. So the in other words, the sound changes should not be like random. They should be things which can be explained using principles of linguistics. So yeah, I don't want to get into any more details because this is all uh, quite complex, and I would want you to read about it. This is very interesting. So Kentum versus Satem, the distinction is that this is one of the this table here, the sound correspondences that you see here is the basis for a split among the Indo-European languages, where you actually so the Satem languages are languages like Iranian, Slavic, and Sanskrit and Indic, where you have the sibilant sh uh, in the word for like 100, while in Greek and Latin it would be kentum, so there it would be a k sound, while in Sanskrit the word for 100 is shatem, which is satem or shatem, So therefore you would see like a sibilant there. So anyways, the whole point of this discussion is we wanted to understand sound correspondences, and we wanted to understand like the notion of establishing genetic relationships among languages. So now, is there a way to do all of this using algorithms and using quantitative methods? So this is again an area which has seen a lot of research in the last 10-20 years. Actually, I would say even more. Tandy Varnov, Gregor Kondrak, and many other people actually. So the papers by these people. So the idea is, are there methods in computational linguistics that can help do what comparative linguists do by hand, do manually? So yeah, so there is actually a class of algorithms which are known as the edit distance algorithm. So an edit distance is basically a method to estimate similarity between strings by counting the number of edit operations required to transform one string into the other. So yeah, and again it's asymmetric because edit distance, so the number of edits required to transform string A into B is not the same as the number of edit operations required to transform string B into A. I won't give any more details here. I will just show you I'll just show you a demo that I found which I thought was quite good. And yeah, so this is a page that I found which gives a good demo of the Levenstein distance. So I'm going to use these two examples. So string A is elephant and string B is elegant. And let's do this. Yeah. So here you can see a visualization of the edit distance algorithm. So the first three characters, there is no change. So you see that the cost up until this point is 0. Then you see that you have so in elephant you would have to there is multiple ways of going about this. So you can actually make it like two deletions. So you can delete the P, delete the H, and then insert a G. So it would be two deletions plus one insertion. So 3 operations, and that's what you have at the end. Or you could also substitute the P with the G, which would be a substitute operation, and then you would delete the H. So again, so here we have, so we can see in the options that insertion and deletion have cost 1 and substitution has cost 2. So the final cost would come out to be the same, but there is multiple ways of transforming elephant to elegant. Again, I would encourage you to read more about this, and yeah, so I will not get into all the details, but yeah, edit distance is basically a dynamic programming based method to estimate similarity between strings. So here are some useful links. So again, the Wikipedia page on edit distance was quite informative. Then I would say, like I mentioned, the Encyclopedia Britannica page on Indo-European languages is quite good. Then the third one is a book on Dravidian languages. So no, the third one is actually a book, a paper on Dravidian languages, and I have a hands-on example as always, and the data set for that hands-on example comes from this paper. And then finally you have a textbook by the late Dravidianist B.H. Krishnamurthy, which you can read if you're interested specifically in Dravidian languages. So again, as always, we'll proceed to the example. Yeah, so I have this repository, and let's look at the data set. So this data set is basically, like I mentioned, I extracted it from the data set used in that paper. So there are 20 Dravidian languages here in this data set, and so this is actually, first of all, this is what is known as a Swadesh list. So it has 100 concepts. So this is also known as the concept of like core vocabulary. So Maurice Swadesh was a linguist who proposed that there is often a core vocabulary of in every language that doesn't change. So we take that core vocabulary here and we take words for each of the items in that core vocabulary in all these languages, and then we try to estimate the interlanguage distance. So I have a script which I created. So again, so from last time, some of the comments I got were that the scripts are, pretty abstract and I'm not going too much into the details, but that is deliberate, that is by design, because I don't want to, make it too simple. And basically, uh, the saying about, taking the horse to the water, but it's the horse's job to drink the water. So yeah, so this is the script. Um but before that, let's look at, so this is the implementation of edit distance that I have. So yeah, again, I will not go into the details, but then you have the same concept. You have costs for different operations, and here you give uniform penalty, deletion, insertion, and substitution. I'm giving the same penalty, but you can have different penalties. Then you compute the Lewiston distance, and then you extract the alignments. Okay, you can read this code, it's fairly straightforward. So now let's run the example. Dict file, Dravidian Swadesh list, Jenny. Yeah, I'll explain what is this in a minute. Jenny, and I think if I recall correctly, sound correspondences. So for this particular example, I will take Tamil and Malayalam, because I think that could be the most useful pair. Yeah, so this script will calculate interlanguage distances for among all the 20 languages. So 20 into 20. So so here you have the sound correspondences. We'll look at them in a minute. But yeah, before I get into that, so let us so I mentioned to you that edit distance is an asymmetric distance metric. So I symmetrify the interlanguage distances. So the distance between Telugu to Tamil is not the same as the distance between Tamil to Telugu. So I take the mean of these two distances in order to symmetrify that distance matrix, and then I use agglomerative hierarchical clustering from SciPy. And so this is actually known as UPGMA if you take the average linkage method. So now let's look at so this is the tree learned from this data set, and voila, you can look at the tree. It's like it makes a lot of sense. So Brahui, Kuruk, and Malto, these are the North Dravidian languages. They show up as a separate cluster. So they are even edit distance is able to kind of find evidence that these three languages are more similar compared to the other languages. And then you have most of the South Dravidian. So Tamil and Malayalam are the closest, as you can see, and then Kannada, Kodava, Yeruva, and Badaga and Tulu are very similar. And so all of these are known. So the Dravidianist late Professor Krishnamurti calls these South Dravidian 1, this family, and you can see that edit distance has managed to recover all these languages as belonging to the same subfamily, which is very good. The only problem is Kota, which is also in the subfamily, is not shown as part of this family. And then you have Kolami, Gondi, Koya, Telugu. So here Gondi, Koya, Telugu, these are Good. These are all in South Dravidian too, or this was also known as South Central Dravidian. But Kolami is actually a Central Dravidian. It belongs with Parji, Olari Gadaba, and Kui is, you know, so I'm comparing the tree extracted using edit distance. The distance is extracted using the edit distance method with the manually reconstructed tree. So when I say this is correct and this is wrong, what I mean is compared to the manually reconstructed tree, these things. Of course, the manually reconstructed tree could also be wrong, in which case this kind of an exercise can inform the manual reconstruction efforts. So yeah, so this is as far as classification into trees goes. But there are many problems with this kind of approach to language classification. But yeah, discussing all of those is beyond the scope of this video. But yeah, maybe I will do a follow up where I discuss problems with using tree structure to represent uh, language relatedness. So now let's examine the sound correspondences. So we can see that these are the sound correspondences between Tamil and Malayalam. So you can see that where you have the dental nasal or the alveolar nasal, the dental nasal in Tamil, you would have the palatal nasal in Malayalam, Nyan, and similarly you have deletion of the nasal in this word, and you see here that you have a sibilant sambal, and here you have the affricate sambal, chambal, sambal. So there is again this notion of systematic sound correspondences that we can extract using edit distance, using the alignments returned by edit distance. So how can these I mean, like, at this point you might be wondering, is there a practical application to this? There is a practical application to this. So when you have, so this same method can also be applied to dialects. So here we applied this method to extract sound correspondences between languages. We could do this exact same to extract sound correspondences among dialects, and this can be very useful when you have to create a dialect dictionary. Suppose you have a, so here, so these words I have extracted from Wiktionary. So these are much more complex transcriptions. As you can see, there is stress marked and there is all kinds of IPA symbols. So here you can align the you can compute the edit distance between the US pronunciations and the UK pronunciations and extract alignments. And then if you see regular sound correspondences, you can use those sound correspondences to create a dialect dictionary. So suppose you have a set of words for which you have US English transcriptions, phonetic transcriptions. You can use the sound correspondences that you've identified to make changes to those transcriptions to create a UK variant, pronunciation variant, and then you can use that in your to build your automatic speech recognition system or TTS system. So yeah, so I actually mentioned this in the readme. So this is actually homework for people who are interested in following up. So you can apply this to the dialect dictionary and see if you're able to extract sound correspondences which make sense and which can be used to generate dialect dictionaries. But otherwise, I think that's it from me for today, and have fun looking at language trees and computing edit distance between different languages. Bye.